Welcome to another video on SRID Cloud. In this video, I want to talk about a testing framework called py.test. It is based on the Python language. So if you want to test anything, you can develop these py.test modules and you can execute them in an organized way, in a structured way. There are so many parameters, so many facilities in this framework. Let's get started. So this is how you can install various aspects of this py.test. First of all, you need a Python language installed on your environment, and I have these commands tested in my Red Hat 8.0 environment. And then you install pip3, the packaging tool for Python 3. And finally, using the pip3 tool, install py.test. And these are the commands to install and verify the Python, pip3 and py.test tools. So now let's execute one of those commands, the Python 3 version, and it's supposed to show the current version. Make sure it is 368, and also make sure the py.test is working. py.test -h should show the help utility for py.test. So now let's write a very simple py.test program and execute it through py.test. So here is a very simple py.test code. It's named as test.py. The name of the file matters here, so it is test.py. And the very top, I import the py.test package, and then I define the test methods. And the first one is test_first1, and in this method, a simple method, I declare two variables x and y and set their values as 5 and 6, and then I perform assert. The first one should go through because x plus 1 is 6, and that should be equal to y, which is also 6, and the test should not fail, the assert should not fail. But the subsequent line, 5 is not equal to 6, so I'm supposed to get a failure. So even though partially this method succeeded, the entire method will be marked as failure because one of the assert statement in it failed. In the second method in the same Python module, there's a method called test_first2, and here there's only one assert, and that is supposed to go through because 6 equal to 6. So because of that, the entire test_first2 method should succeed from the testing perspective. So let's execute it and then see. So here is my the same test.py, and I'm going to run py.test test.py, and it shows that one of the test methods succeeded and one of them failed, and the failure, why it failed and all that. And as you can see here, the file name is printed, followed by certain characters. If it says F, that means it's failed, and a period in green means it is succeeded. And there is a summary statement for failures. So this particular method failed, and this assert statement, x equal to y, failed because x is 5 and y is 6. And it also prints very usefully the values on the left and right side of the assert statement here. This is very useful for debugging purposes. So here is the report. So this report is very, very useful for documentation as well as communication purposes. The test can communicate this to development. So now let's go ahead and then look at some of the features of py.test which are very, very useful actually. So the test file name, the file name is supposed to contain the word test in it. For example, test.py as we saw earlier, or test underscore something.py. In that case, we don't even have to pass the name of the file. You can just say py.test and that should test it. So let's see how it works. So I have the test file name as test underscore something.py. And if that is the case, I don't have to pass the file name. I can just say py.test and hit enter. And that should take care of automatically detecting the test modules and then executing them. And if the file does not contain either underscore test or test underscore, then I have to pass the test file name explicitly. That's exactly what we did when we ran py.test, test.py, because the underscore was missing on either side of the file name. So now let's move on to the method names. So the method names should contain test in it. Otherwise, that method will not be considered as a test case and will not get executed. And of course, all methods with the satisfying name, which is test in it, will get executed automatically. But if you want to execute a specific method, you can invoke py.test with the -k and then the method name pattern as a parameter. You don't have to be exact. You can just say pattern of the test names. So let's move on to the next. If you want a particular bunch of test methods to be executed which are not which don't follow any specific pattern, then you can mark those methods with a decorator, the @pytest.mark.someMarker name. Let us say you have a test module and there are about 5 out of 10 methods need to be tested at a given point of time, but the names of those test methods do not follow any specific pattern at all. Then you can use this approach to execute them only. Just put a decorator around it. Right above the method name, you just say @pytest.mark.someMarker name, and when you execute the test cases, you just pass the -m parameter with the marker name. So then only those methods will get executed. So let's move on to the next one. There is a way to execute the test cases concurrently. Let us say you have a large number of test cases to execute, like thousands of them. You don't have to execute them one at a time. You can execute them in parallel. So if you want to do that, you need to install the PyTest xdist on your environment, and then execute PyTest with a -n followed by a number as a parameter. So in case if you run PyTest with -n4, that means 4 worker threads will be created and your test cases will get executed 4 at a time simultaneously. And there's a concept called fixtures. When you execute your test cases, sometimes you may want to initialize certain variables and keep their states ready and may use them inside your test cases. So how to do that? You write what is called a fixture. You write a method called init method, and inside the method you do whatever you want to initialize, variables or calling methods and things like that, and then decorate that method with @pytest.fixture. Then in your test cases, whose name has to be the name test should be in it somewhere, and you pass in the init method as a parameter. So PyTest will automatically invoke the fixture method before invoking your method. And most importantly, the fixture method, the init method, can return data, and those data will be made available inside the test method. So you can use them for comparison purposes or for invoking some other methods, whatever way you want, you can use them. So in this example, the fixture method, init method, returns an array of numbers 7 and 9, and the test underscore my test, that is a test case, has access to 7 and 9. So the init method 0 is 7, init method 1 is 9, and you can use them inside the test underscore my test method for any purpose you want. So this is very useful for initializing maybe database connections or connections to a server in the fixture method. And parameters. So let us say I want to pass parameters to a particular test case, and I may want to pass different parameters, various combinations and permutations of the parameters whenever I want to test a particular test method. So how do I do that? Just add a decorator at py.test.mark.parameterize, and then key in the variable names within quotes, followed by an array of set of those values. So in this case, the test underscore my method is the test case, and it takes 3 parameters, I1, I2, and then the out is the output coming from the parameterize method, and I'm passing 1, 2, 3 and 3, 4, 5, 6 as the 2 sets of parameters into this method. That means when py.test is executed, the test underscore my method will be called twice. So first it will be called with 1, 2 and 3, and in my method I can take the values 1 and 2 and then do something with them and then compare the output to the value 3, and if it is 3 then the test has passed, otherwise not. Similarly, the second time when it's executed, 4, 5 and 6 will be passed in, so you can probably use the 4 and 5 as the input parameters, execute some logic, something, whatever you want to test, and then extract the output, and if the output matches with the number 6, then the method can be considered successfully executed, otherwise it's failed. So this is very useful to write a generic method, a utility method, and then you test it out with all kinds of combinations and permutations of parameters. So this is very useful, and you can pretty much cover 100% of your test matrix very easily. Very useful for utility method testing. And now for some reason, if you want to permanently mark a particular test as failing, or if you want to skip a particular method, then you can use the decorators at pytest.mark.xfail or at pytest.mark.skip. So in the case of the first one, the at pytest.mark.xfail, the method will be executed but will not be included in the failure report or in the summary report at all. You may want to do this in case if you already wrote a test case but it is yet to be implemented, or the dependent software is not yet available, whatever, then your methods may probably fail and you do not want to call them as real failures. Maybe they are failing due to some reason that you do not you know already. In the case of skip, maybe to save time, maybe you can develop 2 versions of your test implementation. One is a quick one, and the other one is very elaborate one. So in order to execute something quick, you can mark some of the longer duration taking methods as skip. So just decorate them with at pytest.mark.skip. Those methods will not be even executed, even though the method names contain test string in it. So that pretty much covers a very high level overview of PyTest, and with this information you should be able to start writing your PyTest modules and test your software. Or if you already have someone else written PyTest modules, you can understand them better. So thanks for watching, and I hope you understood PyTest from this video, and have a wonderful day and evening. And I will be making a lot more videos on similar lines very soon. So I will see you all another time. Bye for now.